Let's see what Euclid in 300 BC knew about expanding modern-day binomials. It's useful to think about the world political map of the time. Notice that virtually nothing was happening, politically speaking, in the Americas, Europe, or Australia. All the political action was in China, India, and the Middle East, the cradle of civilization. Around this time, Alexander the Great of Macedonia set out to conquer the world. He founded the city of Alexandria in Egypt at the mouth of the Nile River. A great library was formed there that became the world's foremost center of scholarship. Indeed, Alexandria remained the intellectual focus of the Mediterranean world through the Greek and Roman periods until it was eventually destroyed by the Arabs in 641 AD. Euclid was one of the scholars attracted to the city. We know very little of his life before or after his arrival on the African coast, but many believed he studied at Plato's Academy in Greece. He was a math teacher and founder of the Alexandria School of Mathematics. Euclid's greatest accomplishment was the creation of the elements. This work was divided into 13 books of 465 propositions from geometry and number theory. It had a profound impact on Western thought, being studied, analyzed, and edited into more than 2,000 editions over the centuries. Not all of the theorems were original to Euclid. He curated and organized known mathematical results, situating them within a clear, organized, axiomatic framework. Pictured here is the oldest known diagram from Euclid and a picture of his elements published in 1685. You can, of course, find older editions, newer editions, and translations in many languages, including the original Greek, Arabic around 850 AD, in Latin in 1120, and English first in 1570. The first printed version was published in Venice in 1482. The first commercial printing press wasn't available until 1450. Proposition 4 in Book 2 is a result that we know as expansion of a binomial. In modern algebraic notation, we say that the quantity a plus b squared equals a squared plus 2ab plus b squared. Of course, the notion of algebra was unknown to the Greeks at the time, and Euclid's proposition was stated in terms of geometry and areas of squares. Looking at the diagram, we can state the proposition with modern language to say that the total area is equal to the area of the yellow square plus the area of the orange square plus the area of the two blue rectangles. Essentially, the area of the square with side length a plus b is equal to the area of the square with side length a plus the area of the square with side length b plus twice the area of the rectangle with side lengths a and b. That's all I have for now, so until next time, do some math and have some fun. Bye!